Keep heading. Oxidation of aldehydes and ketones. Oxidation of aldehydes and ketones. Oxidation of aldehydes is carried by mild oxidizing agents also, as well as strong oxidizing agents also. Okay. So we discuss mild oxidizing agents and strong also, but ketones are oxidized by only strong oxidizing agents in the drastic conditions, high temperature elevated conditions. Clear? So important point is aldehydes are oxidized by mild oxidizing agents. What are mild oxidizing agents? Tollens reagent, Fehling's reagent, Tollens, Fehling's, and Benedict's. Benedict's reagent. These are mild, three mild important oxidizing agents. And the product of oxidation of aldehydes is, these three will give carboxylic acids, RCOOH. In place of CHO, put COOH. You can take in the form of salt also, RCOONA. Okay, salt format. So mild oxidizing agents like tollens, Fehling's, Benedict's oxidize aldehydes to carboxylic acids. Oxidation products are carboxylic acids. Okay, and strong also product is same only. KMNO4 in all the mediums like acidic medium, neutral medium, KMNO4H plus, KMNO4OH minus, like that, and K2 CR2O7, and even HNO3 also strong oxidizing agent. These are strong. Okay. Now here product, there is no change in the product. Mild oxidizing agents and strong oxidizing agents both convert aldehydes to carboxylic acid. Once look at this. TR stands for Tollens reagent. Fehling's, right? Shortcut. Fehling's and Benedict's. What is the meaning for it? No reaction. Mild oxidizing agents cannot oxidize ketones. Very, very, very important point. How can you distinguish aldehydes and ketones? By using Tollens, Fehling's, Benedict's, any one of the reagent. Because these three reagents oxidize only aldehydes. These three do not oxidize ketones. So we can use these three reagents to distinguish aldehydes and ketones. But strong oxidizing agents like KMNO4 oxidize these to give carboxylic acid, and I will mention very important point. See, strong oxidizing agent like KMNO4 oxidize ketones to water, ketones to carboxylic acid, but less number of carbons. Very important point, less number of carbons compared to parent ketone. For example, what is the meaning of less number of carbons? See, I am taking one ketone, 2-butanone. When we add KMNO4 to this, what we will get? We will get acetic acid. See how many carbons are present? We will get 2 moles of acetic acid. How many carbons are present in it? 2 only. But in the parent compound, how many are there? 4. Very important point. We'll get carboxylic acids with a less number of carbons. We will discuss that in the reactions. Clear? Mention that point also. No reaction. I'll give the statement. Just you write like this. No reaction. Here an important point. Less number of carbons. Less number of carbons as compared to parent ketone, as compared to ketone, this ketone. Okay, make a table. It is better to write horizontally. Okay, complete page, 1 page vertically or horizontally 2 pages. Tollens reagent. This is also called as silver mirror test. Silver mirror test. Tollens test, Tollens reagent, silver mirror test. Under 3 headings we will learn the same concept. Tollens reagent, Fehling's reagent or Fehling's test. Fehling's reagent, Fehling's test, Benedict's reagent, Benedict's reagent. Silver mirror test or Tollens test. See how to learn these 3, how questions will come. I'll give you an idea. First of all, idea about the reagent. What is the active species in the reagent? Okay. Next, when we take aldehyde, how it will converted? Already we know that the final product are carboxylic acid. And the question coming area is, which of the following gives Tollens test? Which of the following gives Fehling's test? Which of the following is Benedict's test? Exceptional cases. Exceptional cases are very, very important in this. Okay, mostly we can see the exceptionals which are Tollens. Okay, right. Reagent you have to remember. Product is already over. Aldehyde. Exceptional cases. You tell me. Aldehydes and ketones are distinguished by this. So ketones do not give this test. Tollens test or silver mirror test, Fehling's test, Benedict's test. Only aldehydes gives, right? Okay. First of all, see this one. Ammonical silver nitrate is also called as Tollens reagent. Ammonical silver nitrate is commonly called as Tollens reagent. Silver nitrate. Common name for Tollens reagent, ammonical silver nitrate chemical. Active species. We have to highlight this. Active species or reactive species. Reactive species. AgNH3 taken twice plus. This is active species, important. In ammonic, this is a mixture of chemical compounds. Okay, formed by adding ammonium hydroxide, silver nitrate solution. Okay, but what is the active species in the reagent? Or you remember what is Tollens reagent means? Say this. What is Tollens reagent? AgNH3 taken twice plus. Remember, Tollens reagent means, say this. This is Tollens reagent, okay? Active species are Tollens reagent formula. AgNH3 plus. Yeah, right. Once it's this is aldehyde. 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 In the test tube, you are taking aldehydes. You are adding TR, Tollens reagent. Tollens reagent. And heating. After some time, what you will observe, this is very important. This what we are discussing, this procedure is important. You will observe formation of silver coating on the walls of the inner walls of the test tube. This is silver coating. Silver layer is formed. You know silver color, but here silver is not there. I am using that. Okay. Ag coating, silver coating. And inside, what is the conversion of the this aldehyde? You know already. Tell me. It will convert it to carboxylic acid. See, this is a physical test. For example, we have given one compound. We don't know that is aldehyde. We are in the lab. We have to find the functional group present in it. This is unknown compound. Okay. We will take that unknown compound and we add Tollens reagent and we heat for some time. And on the walls of the test tube, if you observe silver mirror, that unknown compound is aldehyde. No other compound will give. Exceptional cases are there. Generally we are talking about aldehydes now. I'll give you exceptionals only important. So that compound is aldehyde. Are you getting? This is unknown compound. Add Tollens reagent. Heat for some time. If you observe formation of silver coating on the walls, inner walls, that compound, unknown compound is aldehyde. That is the test details of the test. Clear? This is called silver mirror test, not Tollens test. Ag coating, silver coating. Online students, are you getting? All of you? Are you following? Hello. Active species means we will prepare a Tollens reagent by adding ammonium hydroxide, silver nitrate solution. Okay, means a mixture of compounds we add to prepare Tollens reagent. In that mixture of compounds, only one will come out and that only play a role in the conversion of aldehyde to carboxylic acid. Clear? For example, in your form, I said already, Tollens reagent formula means say this only. Okay, right. I already said that, Adiva. Tollens reagent means say Ag NH3 taken twice positive. And once let us see the reaction. RCHO. You tell me what is silver oxidation state in this? Do you know complex chemistry? Complex compounds. What is the oxidation state of silver? NH3 is a which ligand? +1 now. No. NH3 is a which ligand? NH3 I am asking. NH3. Which ligand? Strong ligand. What about charge? White ligand. Zero charge. Charge is 0. So charge on the silver is plus. Correct. Ag positive. Once observe this, What are the changes you can see here? What are the changes? What are the changes? Srujan, Ag plus is converted to Ag. Silver metal is depositing. Silver metal is depositing. Silver metal is depositing, right? Ag plus to Ag. Now you tell me which is undergoing reduction, which is undergoing oxidation. Ag plus oxidation state is decreasing or not? Reduction. Ag plus is undergoing reduction. Which will undergo reduction? Oxidizing agent. Oxidizing agent itself undergo reduction, opposite property. The one which undergo reduction is called as oxidizing agent, opposite property. Ag plus converted to Ag. During Tollens reagent reaction, we can see this, okay? RCHO to RCOH, Ag plus 2 to Ag. These are the reactions. Okay, forget about this. What is active species? Ag, NH3 taken away plus. What happens when we heat aldehyde with Tollens reagent? After some time, silver coating. Silver coating is formed, right? Okay, now coming to the examples. Main question coming area. Continue in that column only, same column. If you write in the form of column, you can prepare easily. Okay. After completing this column, we will come to this. Right. All types of aldehydes give Tollens test. All types of aldehydes give Tollens test. There is no exception. Formaldehyde, acetaldehyde, benzaldehyde, all types of aldehydes give Tollens test. Right? Examples list. I keep important symbol. All types of aldehydes give Tollens test. Right now, okay. All types of aldehydes give Tollens test. Examples. Say aldehydes names. Which aldehyde name you know, Sanjana? Formaldehyde. Formaldehyde, acetaldehyde, benzaldehyde. Okay. Benzaldehyde formula C6H5CHO. Benzene ring with CHO. Benzaldehyde. All types of aldehydes give Tollens test. No doubt. Right. What about this? Glucose. You don't know about glucose, I think, right? Seniors. Secondly. In biomolecules, it will come. Glucose structural illustration. Glucose contains CHO group. Glucose. This is glucose structure. This is glucose structure. You tell me, you no need to write, just remember whether glucose give Tollens test or not. Important example. In glucose, what is present? Aldehyde group is present, right? So glucose also give Tollens test. Similarly, fructose also, carbohydrates, glucose, fructose. In fructose also, in fructose free aldehyde group is not present, but in the basic conditions it will convert it to aldehyde group. Very, very important. Glucose, fructose. Everyone can identify aldehyde. Other compounds like glucose, fructose. In glucose, aldehyde group is there. That's why it gives positive test. Right, coming to the exceptional cases. We are discussing oxidation properties of carbonyl compounds like aldehydes, ketones. But see, even though some compounds not belongs to aldehydes functional group or ketones functional group, ketones won't give aldehydes functional group. They give positive test with the Tollens reagent. Very, very, very important. Very important. Exceptional cases, 5 number, sorry. Exceptional cases are important. Star marked are exceptional cases. Right. You know formic acid? HCOOH, formic acid. Formic acid. Formic acid is not aldehyde, but it gives a positive test with the tolerance reagent. Why? See this. Draw formic acid like this. H, C double bond OH. This part appearing resembling. This part is resembling which part? CHO. Correct only now. Formic acid is exceptional case. Formic acid is not aldehyde, but it gives a tolerance test. Exceptional case. Formic acid, it will convert it to CO2 gas. CO2. Okay? CO2. Exceptional case, formic acid. Next exceptional case. These are important. Exceptional cases only important. Terminal alkynes. In first year you read this topic, chemical properties of alkynes. Terminal alkyne means at the end triple bond is present. Terminal at the end. Acetylene, terminal. Propyne, 1-butene. 1-butene is terminal alkyne. 2-butene is not terminal alkyne. Alkyne is present in the middle. Terminal at the end triple bond. But look at this. Triple bond is present in the middle. It won't give. Okay. Terminal alkynes Q. Positive test with the tolerance reagent. Completed. Under one column only you are writing all these points. Same column. Next. You tell me, what about ketones? Will ketones give this test? Online students.
No.
Online students. Aisha, Surabhi, others. Bhakti, respond you also. Aldehydes only will give, na? Aldehydes only give. Test with the tolerance. What about ketones? No. But one exceptional case. Alpha hydroxy ketones, very important. Alpha hydroxy ketones give positive test with the tolerance reagent. Generally ketones do not give, but alpha hydroxy. I'll give the reason also. First of all, write alpha hydroxy ketones. Alpha hydroxy, exceptional case. Alpha hydroxy ketones. In alpha position, if hydroxy group is present, that ketone give positive test with the tolerance reagent. Alpha hydroxy ketones. Alpha hydroxy ketones. Look at this. Can I call this as alpha hydroxy ketone?
Yes.
Can we call this?
Yes.
Alpha position. This is functional group. This is alpha position. So in the basic medium, it will undergo tautomerism, keto-enol tautomerism, keto-enol tautomerism, and converted to enolate ion, which is a reactive species towards toluenes. Okay, it will undergo tautomerism to give enolate ion, enol form. Okay, that will reactive towards toluenes test. Okay, that's why I given this example. You have to remember the case. Identify in alpha position OH is there or not. If OH is there, then give tick mark to it. Okay. Functional group alpha position, alpha hydroxy ketone. Can I take another ring example? Alpha hydroxy, yes. Like that, alpha position OH, give tick mark. Reason won't come. Why it won't go? No need to learn, but a case alpha hydroxy ketone, exceptionally, actually ketones won't give, but this ketone give. So you have to focus on this. Next, another exceptional cases are there. What are acetols? Acetols, hemiacetols. Acetal, hemiacetal. Both hydroxy groups are hemiacetal. Hemiacetal also give this test. Hemiacetal. To one carbon. So to this carbon, OR is present and OH is present. This is called as hemiacetal. This dot is carbon. To that carbon, OH and OR is there. That is called hemiacetal. If two OR groups are present, that is acetal. Hemiacetals also respond to the tolerance test. These are additional examples, additional cases. Or this is called as R. See, OR. Carbon OH OR. CH is there now. That is R. O and R. With exceptional cases, this is about a tolerance test. Benzaldehyde, formaldehyde, acetaldehyde, alpha hydroxy ketones, alkynes, terminal alkynes, formic acid. Okay, and glucose. Why glucose gives tolerance test, positive test? In glucose, CHO is there. Fructose also, in the basic conditions, aldehyde will form. Actually, free aldehyde is not present, but it will form. Important example that also. Okay, right. And down. Okay. So your wish. How many exceptional cases you will learn, that is your wish. But basically, basic idea. Tolerance means all types of aldehydes, active species, AgNH3 taken twice positive. What happens? Silver coating formation takes place. CHO converted to COOH. Basic idea. Ketones do not give. What is exceptional ketone? Alpha hydroxy ketone. That basic idea. This is alkane example, and this acetal, that is your wish. Okay, if you are able to remember, otherwise you can leave, nothing will happen. Okay, next, coming to the second column. First column is our, if you write like this, it is easy to prepare. Other students, are you getting? Please respond. Meenakshi, Bhakti, Meenakshi, Ayesha. What about you? Are you getting? Everyone? Surabhi. Phalanx reagent. Phalanx reagent is prepared by the combination of two solutions, phalanx A and phalanx B. Phalanx solution. You write shortcut like this. Phalanx solution. It is prepared by mixing phalanx A plus phalanx B. Phalanx A and phalanx B. Phalanx A is aqueous copper sulfate solution. You have to learn this. Aqueous CuSO. For theoretical questions will come. Aqueous copper sulfate solution. Phalanx A is aqueous copper sulfate solution. Phalanx B is salt of sodium potassium tartrate. Sodium comma potassium tartarate, salt of tartaric acid. You know, just a second, you tell me what is its name? What is its name? Acetic acid. No? Potassium acetate. Can I call it as potassium acetate? If I keep sodium acetate. So this is a dicarboxylic acid. We remove 2H and we keep sodium and potassium. So sodium potassium tartarate. This is acetate, na? Sodium acetate, potassium acetate. Like that, this is tartarate. Carboxylic acid salt. Clear? Structure is not important. Learn the name. Plus NaOH solution. NaOH solution. Mixture of these two. Phalanx B is sodium potassium tartarate plus NaOH solution, commonly called as Rochelli salt. Very important. Rochelli salt. Rochelli salt. Phalanx solution or Phalanx reagent is prepared by mixing two solutions, aqueous copper sulfate solution, sodium potassium tartarate in the basic medium. We take that salt in basic medium. We are adding some base. This is called as Rochelli salt. Rochelli salt. Okay, right. Two solutions. You will get question like this. Phalanx solution is prepared by mixing aqueous copper sulfate solution plus sodium potassium citrate. Sodium potassium citrate.
No.
Sodium potassium tartrate.
Yes.
Tartrate is correct. Active species means, see, what is the meaning of active species? You are taking aqueous copper solution, sodium potassium tartrate, base, everything, but in that which will actively converts aldehyde to carboxylic acid. Let us see. Active species means that reactive part in this mixture. You are preparing phalanx by adding all these, right? In that mixture, which will actively participate in the reaction, which will convert aldehyde to carboxylic acid. That is called as active species. What is active species in tolerance? AgNH3 taken twice, positive. Active species. CuO, CuR, Cu plus 2, CuR, Cu plus 2. You tell me this is cupric or cuprous. Higher oxidation state means? Higher oxidation state. Cupric oxide. Higher is ic, lower is us. Copper is having two types of oxidation states, Cu plus and Cu plus 2. Higher oxidation state is ic, cupric. Basics, cuprous, cupric. So this is cupric oxide. Cupric oxide. What is active species? What is active species? Cupric oxide. CuO. Oxidation state of copper is plus 2 because oxygen is minus 2. CuO. This is the active species. Test details. See what happens. You should know about test. We take a given unknown compound in a test tube. This is unknown compound. We add Phalanx reagent or Phalanx solution, and we heat it for some time. Then what will happen? You tell me. By seeing the diagram, online students respond. Surabhi, Aisha, Bhakti, respond what I am writing here. Just a second. Tell me by seeing this. What happened here? Bhakti, Surabhi, tell me. What happened here? Tell me.
This
Which color PPT? Very, very important. Red color PPT indicates presence of aldehyde in the given unknown sample. You don't know this is aldehyde or ketone or carboxylic acid or alcohol. You don't know. This is unknown sample. What you will do? You add a Fallings solution to it, and you will heat for some time. If you observe at the bottom formation of red PPT, then the given compound is 100% aldehyde. Clear? Right. Why I am giving the structure, this structure, you know, what is the formula of this red compound? One question came. What is the formula of that red compound? You tell me. By saying this. Now I am writing the reaction R CHO CuO gives rise to, tell me, R CO OH and Cu2O. What is the oxidation state here? +1. This is which oxide? Lower oxidation state. Cuprous oxide. Cuprous oxide. So what is the formula of this red PPT? Red PPT formula Cu2. Very, very important for objective exams. What is the formula of that red PPT formed in the Fallings test? Cu2O. Formation of red color indicates that the given unknown compound contains aldehyde functional group. Means aldehyde. Examples list. You know, examples only will come. Examples. All types of aldehydes responded to Fallings test except benzaldehyde. But here benzaldehyde also will give with the tolerance. Clear? See, what is the reason? All are mild oxidizing agents only. Toluene is mild oxidizing agent. Fallings is mild. Benedict is also mild. But if we compare the power, oxidizing power, compared to toluene, these two are poor reducing agents. Mild, poor oxidizing agents. In comparison, overall all are mild only. But if we compare, relative comparison, these two are mild compared to this. That's why these two are unable to oxidize benzaldehyde. Very easy. Except benzaldehyde, what are the examples you wrote in this case? You can copy as it is. So I am giving like that only. Except benzaldehyde. Consider all the examples of toluene category. Consider everything, like exceptional cases, everything you can consider. Consider all the examples. Consider all the examples of toluene case. In the toluene case, what you wrote, you can consider all. Someone are saying something, Adima? Everything you can consider. I mentioned that point, okay? But without a benzaldehyde. That's why no need to write again, time waste. Just you remember. Benzaldehyde do not give positive test with Fallings. So how can you distinguish benzaldehyde? By taking toluene and Fallings. Toluene only will give benzaldehyde. Benzaldehyde and acetaldehyde. I will give the questions also, model questions. See, this is aldehyde, this is ketone. In this case, very easy. No? Aldehyde and ketones are distinguished by toluene, Fallings, Benedict, skips. How many? 4. Because ketones do not respond to toluene, Fallings, Benedict, skips. Okay, clear, very clear. Only aldehydes respond to mild oxidizing agents. Very clear. If I take acetaldehyde, benzaldehyde, then use toluene. This is acetaldehyde, this is benzaldehyde. Okay. Toluene will give both. Next, Fallings. Now you tell. Fallings, which give test with Fallings, acetaldehyde. Benzaldehyde do not give. So the one which do not give the test, that is only benzaldehyde. This is acetaldehyde, this is benzaldehyde. In your hand, Fehling's reagent is there. Add to these unknown compounds. Okay, acetaldehyde responded to Fehling's and give red PPT. But what about remaining? Won't respond. That is benzaldehyde. Distinction of acetaldehyde benzaldehyde can carried by Fehling's test. Distinction of acetone and acetaldehyde. Tollens, Fehling's, Benedict's, Skiff's. Clear? Aldehyde to aldehyde means Fehling's and Benedict's, even Benedict's also. Aldehyde to aldehyde. Aldehyde to ketone means Tollens, Fehling's, Benedict's, Skiff's, etc. etc. Aldehyde to aldehyde means Fehling's. Aldehyde to aldehyde. This is acetaldehyde, this is benzaldehyde. Both are aldehydes only, na? But one is aromatic. How can you distinguish? By using Fehling's. Are you getting what I am explaining? Fehling's reagent do not react with benzaldehyde. Fehling's reagent react with acetaldehyde only. This is acetaldehyde, this is benzaldehyde. Take Fehling's, add 2 drops to both. So which is aliphatic aldehyde, that only will react. Clear? This only will react. You can see the red PPT in this case only. In the benzaldehyde case, no reaction. So the unreacted compound is benzaldehyde. I wrote my here, except benzaldehyde, all aldehydes give positive test with the Fehling's. I will give one chart, table format. Right? Okay. Coming to this Benedict's reagent. Benedict's. Let us consider Benedict's reagent as a solution. Benedict's solution or Benedict's reagent. Benedict's solution is formed by combination of 2 solutions, solution 1 and solution 2. Same, similar to this. Solution 1 and solution 2. Fehling's A, Fehling's B. This is solution 1 and solution 2. Take like this. Solution 1 and solution 2. Aqueous copper sulfate solution. Aqueous copper sulfate solution. Same. Sodium potassium citrate. Sodium potassium citrate plus NO2CO3 basic solution. NO2CO3 solution. See, changed. That is the difference. Citrate and base also changed. There is no particular name for this. There is no particular name for this. Like Ruchelli salt. Difference is salt and base. Right. What are the examples? What are the active species? Everything is same. Everything is same. Copy asked is the active species. The test result, that CuO converted to Cu2O, everything is same. Right here, same, everything is same. You no need to learn anything separately. Same, add all, copy, with examples also. Just difference is reagent. Remaining is same. Everything, diagram, formula, red PPT, everything is same. Okay. RCHO, aldehyde, RC double bond O, ketone. Tollens, give tick mark. Fehling's, give tick mark. React with. Benedict's, give tick mark. Aldehyde can react with the Tollens, Fehling's, even Skiff's, give tick mark. But what about the ketone? You take all this, no reaction. Ketones do not react with the Tollens, Fehling's, Benedict's, Skiff's. So the above 4 reagents are used to distinguish aldehydes and ketones. Above 4 reagents these 4. Okay, 1 2 3 4, the above 4 reagents are used to distinguish aldehyde and ketones. Distinguishing tests also there this week are used to distinguish aldehydes and ketones. You will get names. Propanone and acetaldehyde are distinguished by any one of the reagent. Formaldehyde and acetaldehyde are distinguished by any one of the reagent, because one will react, other won't react. Ketone, no reaction. You can write all the reagents as it is or keep dash dash. Okay, right. That is without exceptional, without generalization. This is okay. Exceptional case. You will get question like this only. Without considering exception, you will get the questions. Okay, model questions are in your material or weekend questions also. Without accepting that, no need to worry about that. Next, see. This is benzaldehyde. Benzaldehyde C6H5 CH1. Tolerance, tick mark. Phalanx, tick mark. Benedicts, tick mark. Skips also, tick mark. Sorry. Here. Yeah. Acetaldehyde, normal aldehyde. I'm sorry. Normal aldehyde. Like benzaldehyde. That symbol also, formula also C6H5CH. Now you tell me. Observe carefully. Tolerance tick or into? Phalanx tick or into? Benedicts tick or into? Into tick mark. So, which two reagents are used to distinguish aliphatic aldehyde and benzaldehyde? Which two? Phalanx and Benedicts. Very important. Okay, acetaldehyde and benzaldehyde are distinguished by Phalanx and Benedicts, because that two do not react with benzaldehyde. Aliphatic aldehyde and benzaldehyde. This aliphatic, mentioned within the bracket aliphatic, like acetaldehyde, propanaldehyde. Aliphatic aldehyde and benzaldehyde are distinguished by Phalanx and Benedicts reagents. Write examples. CH3CHO, AgNH3 taken twice positive. What is the name of this reagent? Tolerance reagent. Phalanx or Benedicts? CO. So what is the product? CH3 COOH. Benzaldehyde to benzoic acid. How to convert benzaldehyde to benzoic acid? By using tolerance reagent. So we completed about the test details. Okay, now examples. Right, but we never get not copper sulfate, active species. What is active species? We mentioned active species. The reactive species you wrote, no? Right. No. Reactive species you have mentioned in that. What is reactive species? Once you see this, we never get direct questions. You completed preparation methods, Sanjana. How to convert Cn to CH4? How to convert? SnCl2 plus HCl followed by H3O plus. Stephen's aldehyde. Now Tollens. KgNH3 taken twice positive. CH3 COOH. Indirect. You know alkyl halides chapter very well. Alkyl halides. How to get this?
By KCl.
Okay. KCl. Interconversions. After completion of all organic chapters, you will do questions like this. Yes, tell me.